Hi, good evening, Rick. Hey, good evening.
Good evening.
Okay. So last session we actually discussed about Docker more about Docker. So nowadays Docker is the foundation of container-based applications. So my containers-based applications, microservices. When it comes to microservices, and container-based applications are used everywhere. So like we had two sessions on Docker. Last two sessions we completely dedicated on Docker only, and we completed as much as possible. So I was thinking of so did you guys actually was thinking like did you have did you get some time to actually work on Docker commands, Docker applications? Um, so I know Rick was not present last week. Last week he was absent, so yeah, I missed the Docker session. I hope he already knows Docker.
Yeah,
Just in case, just in
I
case
mean,
you
I took this course a couple years back, so I am familiar with the Docker. The only issue was that
okay.
the way we did this course before, we used Amazon a lot, so we were able to load up a container in a Linux environment, and basically, and now there is a Linux, uh, there is a Docker in Amazon. I looked it up 2 weeks ago. There is a Docker specialized container that loads up Docker from a Linux box that's available in Amazon. The thing is it cost, it's the usage of the compute time, but there is one specialized. I looked at it like a week and a half ago, 2 weeks ago. But yeah, I've been absent on that. Yeah, so I am familiar with Docker and a little bit on that. I have to
Okay.
practice again, but you know, you know, I have to practice, and I did some practice labs, so I'm familiar a little bit with it. Have I done
Okay.
anything? No, no, I haven't.
Yeah. So actually, so we introduced a new Amazon service last week actually. So that is Elastic Beanstalk. So that is the quickest way we to actually learn about continuous integration,
Right,
how the continuous integration can be done.
right,
So in
right,
the last session, we had a session on how to leverage AWS services to perform continuous integration with the help of few AWS services like S3, Amazon Beanstalk, and IAM services. So combination of these three and Travis, with the help of Travis CA continuous integration, we were able to deploy in Elastic Beanstalk. So that's what we did. And so still there are two courses in Docker still pending. We had actually deployed a single container application. We deployed a single container application in the last week, and um, so we were expecting that we would learn other things like multi-container application deployment and container application deployment with other AWS services as two courses we would actually learn on our own. That's what the expectation was. So, uh, so I was thinking like if we can try that. in this course, in today course live, then we can actually find out, we can figure out, we can have hands-on on how to deploy a Dockerized application via Travis. So if you see that last week we had discussed about topic 10. Topic 10, I actually gave a live demo of it, how to actually deploy a single container application. And later I figured out that to discuss about topic after topic 10, this topic 12 is a bit outdated. So, because AWS services are always upgrading themselves, right? So this has to be changed a bit. So I today I figure out that this is not working as expected now. So this would be like what I would say, like you can actually try it out. I would actually point out what is the problem, what are the problems we would actually face. It is not like we just have to do some little bit of changes in the instructions, and then it would actually work. So I think like we can actually try it out from our side. So if we are comfortable with Docker based CI/CD deployment, which we had discussed in topic 10, then we need to make topic 12 working on our own. We need to actually see what exactly is the problem and how to fix that problem. So because these instructions are good, the video is good, but because Amazon has decided to deprecate few of the feature support that it has done in the past, this is not the updated this is not the updated version that we have now. So we can actually look into this video, and later we'll figure out that few steps are actually few steps will not actually work. So was curious, like we are how many members as now? Like we are four participants, right? Okay. So why don't curious, like did you actually have time to actually create your own AWS account? So I think Shankar, Rick, and Sonalika, ITI. So why don't you actually create your own AWS account now? So this would be like I would actually think like today it should be a hands-on session, and we will make our hands dirty by creating our own AWS application, and try to deploy try to deploy what we have actually discussed in the last session. What we have done, we would actually try to do that on our own, so that we will actually memorize things. So we can actually do step by step, like create a AWS account first. um, Create a AWS account first, and then from there we would use our simple GitHub application and deploy it in the AWS. So why don't we do that step by step, so that we remember, we would be confident enough that we know how the CI/CD pipeline works with the help of Travis. So that's what we would actually we'll go today. What do you think?
I'm okay. I already have an AWS account. So
Yeah. Um, so if you remember last application, I have already demoed in the so last demo I have already mentioned how to actually create a AWS Beanstalk application. So I can actually give an overview, and I would encourage everyone to actually do a quick deployment and see how it goes. So like you have Beanstalk here. So why instead of just to try to create your, if you haven't created your own AWS account, try to create a AWS account, and try to see the services now, like Elastic Beanstalk application, how to create a Elastic Beanstalk application, and how do you create So first step is like create AWS account. First of all, finally you have to just create a AWS account. Um, go to AWS website, and here you can actually sign up for a free account. You can actually create a free account. So just click on this create a free account and enter the credentials here. Sign up for AWS, and you will be provided an AWS account, a free tier AWS account, which you can use to further learn about deploying into AWS using Travis CIC, sorry, continuous integration. So,
Anil, I can
so
create a root user, right?
yes, by default, you will be a root user.
Okay, after root user, I mean, giving the details about that, it's asking for the billing information.
Billing information. Yeah.
Yeah, in that it's asking for the credit card number and all.
They you will not be charged. They will be just storing the credit card information, but unless you use the services, then only you will be charged. It is pay as you use service. So though you provide your credit card information, it will not be charged unless you use the services. So basically, if you create a EC2 instance and keep it for 2 3 days on, then only it will be charged. Like as you go on using your services, you will be billed. But if you don't use any services, you just create an account, then you will not be charged. So basically, so to learn, at least like we have to create a account, and even Travis also will ask you for credit card information. Travis. So basic Travis, you can actually just go for free trial and give the credit card information. Afterwards, minimum it will give it for 30 days, and within the 30 days, you can actually learn about Travis CA also. So just create a AWS account, and it would be good.
Okay, so will it be safe actually when we are giving this credit card details and all?
Yeah, we can trust Travis and Amazon Web Services for sure.
Okay.
Actually, when I
Yes,
actually I created AWS account 5 years back, and somehow I got some credits, actually free credits.
Mm-hmm.
So there means like you will not be directly given for, but there will be some link within inside saying that you would be requesting for free credits. I did it 4 years back. Until now, I am never charged. So I am still using the credits only till now, like since 4 years. But even without credits also, you will not be charged unless you use the service to much extent.
But
Like
when we are after creating the AWS account, so inside that we will use some uh, like app we will deploy, and we will use GitHub. So we will deploy in GitHub. So those things we will do inside the AWS only, right? Or because it
deploying.
will consider as a service which you are using, right? That also it will consider as a service, or how it is?
No, no, GitHub is not belonging to AWS. In AWS, we will be in this tutorial. We will be using two services basically. S3 service, which is almost free. I was never. It is like free for life. Most of the time, I was never charged. Like S3 is like the cheapest service that you can see, and I think we use it for free most of the time. S3 services. And other service that you are going to use for now is Elastic Beanstalk. This is the service that you will be using. These are the two services that you will be using as a part of a CI/CD pipeline for now. But it doesn't require you for, means like CI/CD is a generic tutorial. We are using these two services for our learning purpose to get an idea of how CI/CD is working, right? So now you have having questions in your mind, right? So when you actually try to practically implement, then you get an idea of what exactly which services are used for which purpose, right? So as you have asked the question, right, like GitHub and all those things are, when you use GitHub, it will not be charged. GitHub is a completely different. It is out of AWS, so you can actually use GitHub public repository for free for lifetime. So you can just create your own repositories, right? For
Okay.
the sake of the learning of
No,
CSS.
GitHub, when we are using GitHub, that is okay. That is free of cost, and we can use it freely. That is not my concern. Is from AWS, when we are connecting the application to GitHub, I'm asking.
Yes,
Intermediate, any service we want to use or something like that.
yes. So
For that
intermediate,
service, do we chargeable? It's chargeable or not? In that point
yeah.
of view, just
So in order to connect GitHub with AWS, in this particular demo, we are taking help of Travis. So Travis, we have to create an account. Again, Travis is also commercial account, but it doesn't charge you for 30 days for sure. So when you actually open a Travis account, so like to answer your question,
because let's say for example, we have Azure, right? Microsoft Azure. So
mhm.
in the Microsoft Azure, we will create app services.
Hmm.
So from the app services, we will connect to the GitHub.
Okay.
So application will be deployed in the Microsoft Azure. So
Hmm.
from that Azure, we will connect to the GitHub. So in between app service we are creating, right? So
Yeah.
based on the app service utilization, so that will be chargeable. So in that point of view, I'm asking from AWS like that.
Got it. So what the functionality app services does, the same functionality is done by Travis.
Okay, okay.
So Travis is doing the same job. Travis is basically a continuous integration tool, and it is commercial tool, and it actually charges you. It charges you, but it doesn't charge you for the first 30 days for sure. So when you actually create an account in Travis, start building, when you create an account using GitHub, you can sign up with GitHub directly. Basically Travis is works with all only these branches, so you have to sign in with either GitHub or Bitbucket, GitLabs, and or this one I never used, Assembler. So 99% everybody will be using GitHub. So when you sign up for Travis, it will ask for your payment credentials. There will be three plans they will be opting for. So whether you want to go for free trial, or you want to go for professional, or whether you want to go for some other. There are three offers they are actually provided. Three plans they will provide you. And the first plan would be a free trial. Free trial in the sense like it is free for first 30 days for sure, and unlimited number of users and unlimited number of commits that you can do for 30 days. So that one you can opt for, and after 30 days, maybe like for safe side, you can just delete the account. You can just delete the Travis account. So that is what. So as you have mentioned, you are using DevOps, right? Azure DevOps for connecting with GitHub, right? Similarly, like DevOps only, probably we can actually work on DevOps in the next session. Azure, we can shift on Azure DevOps and see how the DevOps CI integration will be happening, right? But CI integration means like Travis also is equivalently very famous tool, commercial tool. So we have opted to teach Travis also. So in order to learn Travis, we need to have a Travis account for at least like 30 days. 30 days we can just have it and learn. So once you have a hands-on on Travis, right? Afterwards, you can just remember the Travis syntax, how it works, and you can just remember how the Travis.yml, how to code in Travis.yml, and it will be a good learning for you forever. Though you can actually just delete the account after 30 days. You can just, or if you don't use it at all, it will not. I think it will never charge you. So for the first 30 days, it will be charged. That's it. So if you install Travis, if you open AWS account is like pay as you go service, right? If you don't use any of the service, suppose you have created EC2 instance in AWS, and immediately if you delete it, then you will not be charged. So if you open a EC2 instance and you continue to work on it as time goes, you work on multiple AWS services, you use S3, EC2, and like other services like routing 553. Other, if all services, if you go on using, then you will be charged. But if you don't use the services at all and you just create and delete it, then it will not be, you will not be charged much. So the point is like, in order to learn the pipeline, like you need to have a account for sure. So quickly learn it and remember what the flow. Then like few of the services are completely free, like IAM service, like this is the IAM service of AWS. IAM services of AWS is completely free. You can actually, so there is a separate, the people actually teach separately IAM services. It is a core of AWS. Like if you want to use any of the services in AWS, first of all, you have to learn how IAM services works. And IAM, if you play with IAM services, then you will not be charged. So IAM is completely free for you. So there are many services in AWS which are free. We can just use for learning purpose. And few services are pay as you go, Like if you create EC2 instances and you completely work on it, you deploy, and if you deploy an application and you try to use that application, if you create some databases, AWS has few database services, right? Like RDBMS, DynamoDB. So those are like pay as you go services. So if you use them, then you will be charged. So make sure that after you learn, you just delete the service. That's why actually, after giving the demo, I generally delete all those applications that I have created. Got it, right? So yeah, so IAM services for sure. Like if you have AWS account only, then only you can work on IAM services. You can create users, create roles, policies. There are already inbuilt policies. You can just do a live visibility. You can get live visibility of what are the already inbuilt policies that AWS provides you. Last session, if you remember, I have created a user. I have created a Travis CA user here, and I have assigned, for demo purpose, I have assigned full access rights to S3 and full access rights to AWS Elastic Beanstalk. So you can actually learn if you create your own AWS account, and if you do it by yourself, you can memorize it very easily. Right. So like AWS has a lot of services. There is a lot of learning curve that you can go. Machine learning is also there in AWS, right? So if you have an AWS account, you can just play with them. So yeah, so it's a good idea. Like if you already have Azure account, then probably I will plan to give some sessions on Azure also. So as it comes to DevOps, Azure also provides some standard DevOps solutions. So probably we can actually go for Azure Web Apps and Azure DevOps services, and we can actually visit them. I'll try to cover, but let's see for now. Let's see how to work with Amazon AWS. So just create a AWS account and create a Travis account. Then we should be good to go. So I have created a Travis account. Now I have when I created Travis account, what I made sure that I sign up with GitHub. So if you sign up with GitHub, then your Travis will be integrated with GitHub, right? So once you integrate Travis with GitHub, then you can just see that integration in your profile. In your profile, there is a list called applications, applications. Here in the application, you can see that Travis is actually mapped with your GitHub. So this is where how the Travis will take care of deploying it to AWS, right? So to answer your question, right, how Azure is mapping GitHub with Azure services, right? Here, Travis is mapping your GitHub with Azure Elastic Beanstalk via a simple YAML. So that YAML I already have discussed in the previous session. So the point is like we will forget things. Though we have all covered it, we will definitely not be able to remember things because they are of different syntax and they are different languages. It will just skip up of our mind. So to just remember it, either we have to iterate through it 2-3 times again and again so that it will be stored in our memory, or you can practically implement it step by step. And once you have the success flow, end-to-end success flow, right, you will get the confidence. Then you can say that, okay, I understand each and every stages of the CI/CD that I have implemented by myself. So that is the point. If you implement it by yourself, you can get a visibility of how you are using all the services, right? Now, like last session, I have introduced lot of services at one 3 hours seminar. I am sure that people will definitely forget if they haven't practically implemented it. So I think I listed out the services list last week. Um, Yeah, so last week, right? Let me do a big presentation. How to Mhm. So these are all recorded sessions. So we already have the recorded sessions probably, but because of our busy life, we might not be even getting time to. We don't know how to actually see the recorded sessions also, right? So that would actually be a good thing. Like I would actually say how quickly you can learn how by what exactly you have to look for in the 3 hours of recorded session. What is exactly thing that you might be interested in? If you don't have time to actually look into the entire record session, probably only required things you can actually look into in your record sessions. So the point is like if you remember the entire thing, then that's great. But if you forget what we had teased in the previous session, then that will be like of little use, right? So if we have to iterate to it, so good things like learn the same thing again and again to become expert rather than learning everything and remembering nothing, right? So basically, at least like learn one thing, get expert in one area, right? So last week I will again iterate what we have learned. We have learned when we started with Docker, right? We started with the EC2 instances of EC2, right? Let me see if I can increase the points. So what AWS services we have learned? So we have learned, we introduced Docker in EC2 in last session. So people who are experts in Azure, right? They can also try the same thing what we have done in EC2. So we have something called VMs in Azure, right? So if you already have a Azure account, right? So then better go for VMs. So the same steps will actually work in VMs also. So in EC2 in the beginning of the Docker session, what we have done is like we try to install Docker inside the EC2 instance, and we played with, like, we created sample Docker containers, we created images and all those things. So this is the services of the AWS that we have used to actually learn about Docker in online, right? So we created a nginx container, and we gave a live demo of simple opening nginx, which defaultly opens in 80 port, right? So this is what we have learned. After that, in order to learn continuous integration and continuous deployment as a demo, we used a few of the AWS services, and we took help of one CA tool, right? The CA tool that we have taken care of is Travis. Last session, what we have used is the Travis. Travis is the CA tool that we have used in the last session. This CA tool basically, like, it's as simple as we need to first to do CA tool, you have to just create a Travis account first of all. Okay, so you have to create a Travis account. And when you create a Travis account, you already create account with existing GitHub account. You don't create a separate account. So as I already mentioned in my Safari browser here, so using creating a Travis account, it will defaultly ask for which of the version control system you are going to use to actually create a Travis account. So we use GitHub to create a Travis account. So we took care to understand CI/CD pipeline. We took help of Travis CA, where we created a Travis account, and we took care of Travis account and a syntax called travis.yml travis.yml. So these two things we took care, we took help of Travis tool, right? After that, we introduced few AWS services. To understand CI/CD tool, we took help of Elastic Beanstalk. Elastic Beanstalk. Okay, so this is what we actually took care of. So it is similar to web apps. Web apps in Azure. In Azure, we have something called web apps. So it is similar to web apps in Azure. Azure web apps. Okay, so if you want to use only Azure only, then we can actually experiment with the Azure web apps. I think this is I will just confirm it. So if in order to see what all the DevOps tool Travis actually supports, so we can search for Travis list of providers. So we can see list of all providers for Travis, right? So yeah, so you remember last session we already discussed. This is the huge list of providers that Travis actually supports, right? In Google, there is something called Google App Engine, which is similar to Elastic Beanstalk. Google App Engine. In Azure, we have called something called Azure Web Apps, which is again similar to Elastic Beanstalk. So Elastic Beanstalk we already discussed about in the last session, how to deploy in Elastic Beanstalk. So if you understand the concept, right, the same thing like AWS Elastic Beanstalk is same like Azure Web Apps. It is actually same like Google App Engine. So these all three things services almost behave like the same thing. So these are the list of all the supported providers Travis supports. Like, so the syntax of all the syntax of how to actually connect with these services provided AWS services or Azure services, you can just click on it. Like web apps, if you can just click on it, you can see the syntax. You can learn about the syntax, right? This is the syntax that is used for Azure DevOps. If you already have an Azure account, you can try this thing. Okay. So, but what we have used is Elastic Beanstalk. So, Elastic Beanstalk, you can go. So, this is the syntax for Elastic Beanstalk. This is the syntax. Like the deploy provider is common across all the services, whether is it Azure or AWS. But the below after provider under Elastic Beanstalk, what are the supported keywords is different for different applications. So we have gone through AWS Beanstalk specific keywords. So that's what we have learned. So that is very clearly given in our session. If you see in our session, if you go to our CloudX lab, if you go to our CloudX lab sessions, so there you can go to that specific if you go to that specific course topic, go to this particular topic, you have the GitHub repo already there, right? So I am actually reiterating what I have already taught in the last session so that we can remember again. So we already gone through this particular GitHub link. Just open this particular GitHub link. Here you can see that there is a file called travis.yml. So last week what we have done is we have a simple HTML page we have gone through this particular simple repo. This is all the code we have in our GitHub. It's a simple HTML code. We try to deploy in Elastic Beanstalk. So in order to deploy in Elastic Beanstalk, this is the syntax that we have followed. So all we need to do is like we have to create travis.yml, whether we want to deploy in Azure, whether we want to deploy in Google, or whether we need to deploy in AWS. We need to definitely have a travis.yml, and this is the syntax for Azure Elastic Beanstalk. So here you can see that the provider is Elastic Beanstalk, right? The provider is Elastic Beanstalk. So using once you say that provider is Elastic Beanstalk, it will try to connect to Elastic Beanstalk. Now, how do you connect to Elastic Beanstalk? What are the credentials that you use to connect to Elastic Beanstalk? Is all given here in the below itself. So here it may look a little bit confusing, but it is pretty simple. So the code is not at all difficult at all. All we just need to understand the flow once, then we will feel confident about it very easily. So it clearly says that you want to connect to AWS Elastic Beanstalk, and this is the credentials that I am going to use to connect to Elastic Beanstalk. So these credentials like AWS key ID, AWS secret access key. So this is the credentials that you are going to use. And we need to learn how we are going to generate this key and access key. We need to learn them. So that is also pretty simple. Just now you asked, right? We have to use root credentials, Shankar. So you asked me whether we need to use root credentials or not. We can use root credentials, but it is very much recommended not to use. It is highly recommended to not use root credentials. We should never use root credentials because you're compromising on your security. So root credentials, once root credentials is compromised, then your entire AWS account is compromised. It is a high risk factor. Never use root credentials for any of the service. Root credentials should be kept as secret as possible for forever. And for each service, or depending upon the service that you need to run, you just create another account. That I have given a demo in the last week itself. It's like as I mentioned, there is a separate service called IAM service. So this is a completely free service for lifetime. So IAM services is provided by AWS. You can create as many users as possible. So here you can go to users and you create your own user here, like travis.ca. That is what I have created in the last session. So once you create this particular user, right, I can just create another user now for you. So like I can say demo user. It is a demo of how to create credentials, right? So last session I have given this demo of how to create a user. So you just create a demo user, and user can be a human user or programmatic user, right? So in this case, travis.yml via YML you are trying to deploy. That is, it is a programmatic way of deploying, right? So you check this particular box, access key, programmatic access. So you check it, and then you just follow these steps. So these steps are pretty straightforward, pretty very simple. You just need to follow these steps. So you are trying to create user. It is giving a simple sample example, like whether you can actually, it is giving a hint saying that this particular user, you can have S3 access. You can attach more policies to it, like going to this particular policy, and you can attach as many policies as you want here. So AWS provides you many of the policies, inbuilt policies, ready-made policies for you. So you can just use those ready-made policies. Otherwise, if you feel like, okay, I want to create my own policy, then you can go for this particular thing, create policy. So you can create your own policy also. It is a fine policy editor. You can just create policies that is a completely different syntax that you need to learn, and or you can actually just create, if you are very much if you know the syntax of how to create a policy, it is a simple JSON. So you can just say your policies like read write access star dot. There is some syntax, okay? So you can actually create your own policy. Otherwise, you can use your existing policies by clicking on this particular policy and say. So in this case, if you want to create, if you want to attach Elastic Beanstalk policies, for the demo purpose, I have given full access of Elastic Beanstalk. So I have just gave administrative access of Elastic Beanstalk. So this is what I have given. So S3 also I have given complete access. So S3, you can go Amazon S3 full access. This is what I have given. And then you go on clicking next, next, and then just you create the user. So last week I have demoed you how these steps are done. And then once you say, once you are come final step, there will be a create user. Once you click on this particular create user, right? You will get the access key ID and secret key also here. So this is what you will get at the end. So these are the credentials, programmatic credentials for the user that you have created. So here you have created a user demo user. Instead of using the root user, you have to use this particular demo user. So this demo user has access to only S3 and Elastic Beanstalk. If your services are compromised, only two services will be compromised. You got it right? So
Anil, I have one doubt actually. So this demo user is belongs to the IAM user.
yeah,
IAM
so
user is different.
yeah. So IAM is a service. IAM is a service like S3 is a service. So it comes in list of services. So to create, delete users, policies, security groups, all these things, you use Amazon service called IAM. So IAM is a particular service. Using this service, you create users which can be used across all services. Okay.
Okay. Okay.
So if you want to use S3,
So it's a kind of one of the account, right? It's
yeah.
also one of the kind of account.
Yes, it is one kind of account only. So, so if you want to,
So instead of this demo user, can I able to see in which IAM user I have created in the AWS?
yeah,
Like this,
you can.
you have shown, right?
You can just go to the users list and there you can see what are the users you have created. So I just now created IAM user, right? I demo user, right? So it will come in the users list now. So if I click on this particular, let me, so if I click on this particular user, right? Then you can see that this demo user is also another user that you have created. Okay.
Okay.
So demo user is one user, travel CA is another user. These are many other users also. So there are four users, and each user is created for one purpose that the administrator has decided. So administrator has decided, in this case, I have decided that I will use demo user to access S3 and Elastic Beanstalk only. So this is what I have decided for. So use, and also like remember, so this is not a UI user, it is like programmatic user. So which can be accessed via program. So any of the services, right? Any of the services in AWS, like whether it is S3 or these are all the list of services like databases and all those things, right? So all the services can be used only via some user account, right? So all these users should be created by us via IAM services. You have to create list all the users in this particular. You have to come to IAM, and here only you can create users and use these users credentials to access any of the services. In this case, Elastic Beanstalk. Okay. So now I have created demo user. Similarly, I have created Travis user in the last session. So in order to use Elastic Beanstalk, I have created this user. Now this user, using this user's credentials, I will actually access the Travis. So this is programmatic. In order to programmatically access this user, I will copy this AWS key ID, secret key ID. Instead, I can create a human user also. For that, for creating human user also, I have to just go through IAM flow only. But instead of clicking the programmatic access, I will just say that he's a human reader, right? So it is as simple as while you create the service, here when you create a user, when you actually create a user, maybe like another user, maybe user one, this is the second checkbox I will check in password. So that means like he can actually explicitly log in using his own password. He can set his own password, right? I am creating another account. So it is similar like account what you have mentioned. So if I click on this particular thing, right, that means he can programmatically access instead of manually entering password. He can access via program by providing access key and secret key. But he can, if you click on this particular password, he can access those services using passwords, using the password which he can automatically decide what password he wants to use, so that no one can actually know. Got it, right? So we can create two kind of users. One is like programmatic user, and the one is like password based user. So we have created programmatic kind of user now. Okay. So got it, right?
Yeah,
Okay.
yes, sir.
Okay, so now you have an account, what you call it as user here. In this case, we have created demo user or we have created Travis user, right? So last session, what we have done is we used Travis CA and we wanted to use Travis CA to connect to Elastic Beanstalk. But Travis CA should have some credentials to connect to Elastic Beanstalk. So in order to provide credentials to Travis, what we have done is we created a programmatic user like this one only. Last week we created Travis CA. This week today we have created another user called demo user. You can actually download the credentials by clicking on this particular button, download CSV. So you once you download, this CSV can be simply contain the same information that you are seeing here, right? This access key ID and secret access key. This will be one time only you can see that. Second, next time you can't see the same secret key. So somehow you have to remember this particular secret key by downloading it and keeping it the secret place, right? So this is the access key ID, secret key ID that you are using for the demo user. So this is the credentials for the demo user. So this way you can actually always remember the credentials and use these credentials. You can provide these credentials in your travis.yml. So you just go to the travis.yml. If you remember, in the travis.yml in Elastic Beanstalk provider, you have to provide those credentials. So you can provide those credentials via the environment variables. So if you remember, this is a simple example of, this is another example. Let me go to the previous example. So this is my first app where we have created a simple HTML. This travis.yml should be provided with the credentials, right? These credentials, key and secret key, I am providing a simple key variables, AWS access key, AWS secret key. So these variables, what are the values of these variables? These are simple variables, right? But you have to copy these values, right? That values that you have copied it from the download file. So these values, right? This is the actual value, access key. This is the secret key, is the actual secret key. These secret key must be given to Travis, but you have given the variable names only. So how do you define these variable names? You have to go to your Travis account. Here, in your Travis account, you have to go to that particular repo, or generally you can just go to the dashboard. If once you can just go to the Travis dashboard. After you create a Travis account, you can go to the dashboard, right? You can dashboard. You will see the list of all GitHub repositories that you have created. See, this is your GitHub repository. You have mapped to. So like here, this is your GitHub repository, right? This is your GitHub repository. So in your GitHub repository, how do you map all your repository to Travis? How do you map your GitHub repository to Travis? That I have discussed in the last session. How do you do is like in your profile settings, go to your profile settings, here settings, click on the settings, you have integration section. This is integration section. In this application, you have to go, you can see that Travis is already integrated in your account, GitHub account. So there is a configure button. In this configure button, click on this configure button. There you can see, select what repositories you want access to Travis. You want Travis to access to, right? So this is you can say that I want to give Travis access to these two repos, my first app and user wishlist. You can add more also. You can say that, okay, I want to give access to this particular repo, deep matrix UI. I just click it. So now you have given access rights to Travis to these three GitHub repos. Your three GitHub repos must be accessible by Travis. So you just save it. Then you will be redirected to Travis, which is similar to what we have here, right? Here. You just refresh, you again click on this particular dashboard. Now you can see that we have three repos, right? So Travis can do the build process, circle CI pipeline, because you have given access to these three repos. It can perform CI/CD pipeline operations on these three repos. So Travis has access to these three repos to perform operations on. So you can just go to this particular any one of the repo. In our case, we are actually looking into my first app repo, right? So go to this particular settings. Go to this particular settings. Now you remember that you still didn't give your access key IDs and secret key IDs. You still didn't give, right? You just give the variable names here. So in the travis.yml, you have just given the variable names, AWS account key. But what is the value of AWS key account? You can mention it here. Here, going into the settings. In the settings, here you provide environment variables. In environment variables, you can give what is the value of AWS access key, what is the value of secret key, Docker ID, and so on, by just doing copy paste. So you just need to copy this value and paste it here. It will not be visible. You can just paste it here. So this way, now Travis knows your AWS credentials. So Travis has got your AWS credentials via this environment variable. Now using this environment variables, you have given access key and secret key of this particular environment variable. Right? This is belonging to which user? It is belonging to this particular user, demo user or Travis CI user. And remember, what are the access rights policies? It has policies to only Elastic Beanstalk and S3. You remember, right? It has access to only S3 and Elastic Beanstalk. So Travis can access AWS services only belonging to only those two AWS services, S3 and Elastic Beanstalk. Only those two services can be accessible via these particular credentials, because these credentials belongs to that user which has access to only Elastic Beanstalk and S3, right? So if you have any doubts of what access it has, what access it does not have, you can simply go back to your IAM and go to that particular user and see what policies it actually has. So you can just go to that particular user, Travis user in this case. Here you can see it has access to only S3 and Elastic Beanstalk. Only two access it has, right? So this way you make sure that you don't access all the AWS services, but only those services this user is supposed to do. In this case, only Travis has access to only these two services. Now, once you have this mapping done, right? All you need to do is give instructions to Travis what you need to do as a part of CI/CD pipeline, right? So if you want to learn more about what are the things that you can do, you can just go to this documentation of Travis. The documentation of Travis will give you all the provider specific things. Most of the time, there will be limited number of keywords. You just need to learn about these keywords. Okay, so they are pretty straightforward, and in this case, we have already done a demo of it, and it is pretty straightforward. You can just re-verify it by looking into the travis.yml. It is self understandable. So you just go to that particular YML, and there you can see that it will be actually deploying to Elastic Beanstalk, right? So that you can actually mention, you can see that um, by going into the repo. So you can just look into this travis.yml, right? So what it is doing is like, it is trying to deploy to Elastic Beanstalk because you have used a provider Elastic Beanstalk. It is trying to deploy. You can see this particular keyword deploy, right? So for every commit, it will try to deploy to Elastic Beanstalk, which is there in region AP South. AP South one is for Mumbai. Okay, it is AWS way of mentioning there, and in fact, it is used in all services. Even IBM services, Azure also uses the same kind of nomenclature. So AP South is actually for Mumbai, and application is the Elastic. What is you are saying Elastic Beanstalk, but Elastic Beanstalk can have multiple applications, right? So you have to give the application name and environment name, and what are the credentials that you are going to use to access the Elastic Beanstalk, and what is the S3 bucket that you are going to use, and so on, right? So this and for what commit, for which branch you are going to commit, main branch, right? Main branch you are going to commit. So this is very simple YML, and you have to just write these 8 lines. Once you write these 8 lines, you are good to go for performing the continuous integration using Travis.
But I have a question.
Okay.
I followed the instructions, and I do see the push of the YAML file into our GitHub, which is pretty much tied through the Travis CI, which performs the CI/CD deployment. But my question becomes, if you do an underlining change in the Docker image, because you're not pushing anything in that Docker image, how does Travis CI interpret there's been a change in the Docker image, and it performs the testing, and it performs the actual integration and the deployments? My understanding is that you're loading up an S3 bucket. What I'm reading, I wasn't here last week, but we have the YAML file sitting in an S3 bucket.
Yeah, I got your question. Yeah.
Yeah.
So what your question is like, if you make any changes in the Docker image itself, then how do you make sure that the image changes are also getting reflected as a part of CI/CD, right? Yeah. So basically, we didn't cover that here, but so Travis has and we have already have that example actually. So there is like we have deploy. There is another keyword called on success. On success. What we can actually do is we can make sure that we deploy the latest image to Docker Hub, right? So Travis has a way of deploying first the entire image to the Docker Hub, and from the Docker Hub, Elastic Beanstalk will actually pull that particular Docker Hub specific image to its environment. So that is the way it works. So that example, I'll just give it to you. I have that in the repo. So we already have another repo for that. I'll just show you that example. So I think this is the user wishlist app. If you go into this travis.yml, so this is what we have here. Okay.
Right, but my question is, that's that's your YAML file, isn't that correct? This is
Yeah,
the
this is
YAML
our
file?
travis.yml.
Right.
Yeah.
Okay, so my question becomes, is this, is there a webhook or is there a detection that Travis knows that he needs to take the image, put it in the hub, and then, and then fire away the Elastic Beanstalk?
Yeah,
It,
so
it,
that is what we are doing here.
right, but
So
how does it, I know, I see, oh, there's an echo there. uh, But how does it know? Because the YAML file is just an instructional file. That's all YAMLs are. YAML is just an instructional file, just to, giving instructions where, certain objects are sitting and what to do. But how does it know? How does it detect that there is been an image? Is it looking for a Docker build somewhere that triggers the actual Travis CI to fire away? I mean, how does that work? That's what I'm trying to see. So it's listening to a build in the Docker file, right? Is that what it is?
yeah. So what happens
That
is
was
that,
that's my question. Is it listening to a Docker build?
yeah. So it
Okay,
will listen to the
okay.
Docker build. Yeah.
Right. So there is a Docker image that's looking at, that's pointing to
Mhm.
that. Where is the Docker image ID in the YAML file? Is it somewhere in there? Or,
Oh, okay. So Docker image ID is here itself,
oh,
right?
okay, I got it. I see it. I'm sorry. I see it. Okay, I get it now. So it's listening for a Docker build for
Yeah.
that image. So it's really listening that Travis I it's actually listening to the Docker image, whether that's pointing in the Docker hub.
Mm.
That's what it's doing. So it's constantly listening to that. Okay, I got it. All right, that
Yeah.
was my question. Yeah. I'm
Yeah.
sorry I was in here last week. I'm sorry. My apologies.
Yeah. In fact, Travis has multi-container deployment as well. Instead of having only one Docker file, it also supports Docker Compose also.
Right, Docker
So
Compose, right? Several builds.
yeah, several builds. Yeah. So in this example, we already uh, have that demo as well. So user is,
Okay.
you can see that Docker Compose YML. Um, so you just need to have, you need to mention multiple Docker, using Docker Compose, right? You can actually build multiple Docker containers, Docker images, right?
Mhm.
So similarly here you can actually have multiple containers, like you in this particular example,
Yeah, I see
Docker
two
Compose actually
services here.
is a set
Yeah,
of
I see three
services.
services. Yeah, I see the services. You
Yes.
have a Redis, you have a
So
database
yeah,
service, you have a Flash service. Yeah, I see it.
right. So here you can actually mention, like here image for Redis service, it is taking Redis 6.0.8 from Docker Hub, from
Mhm.
Docker Hub. So DB, it is actually taking Postgres 12 from Docker Hub. And for web services, it is actually relaying from your local
Right,
folder.
right.
From your local folder, it is taking the Docker file, right? So you can have in not only single Docker images, you can actually work on multiple Docker images. But the thing is like this particular user wish list is little bit outdated because Amazon has suddenly decided to deprecate uh, one particular container, one kind of container. So it has to be little bit tweeted, but after I will actually commit the later with the latest changes so that it will work. So I
Okay.
would actually encourage you to actually go um, to our course. So our course is pretty much updated with deploying single container, and it already has a running demo of this particular GitHub repo. But when it comes to multi-container deployment, which I already mentioned in topic number 12, in deploying multi-container deployment, if you actually look into the video session, it is very finely the demo is very good, but
Okay.
the Elastic Beanstalk, one of the feature is deprecated. So we need to do a little bit of change, and that would make our GitHub repo, this user wish list,
Gotcha.
also working. So this user wish list actually has For quite good integration of Docker Compose YML and Docker AWS JSON with Travis.yml, but it needs to be a little bit tweeted. It needs to be tweeted. I will actually update those changes and probably commit those changes there. But I would actually show you what has actually changed in Elastic Beanstalk. So let me continue a little bit later. Let me continue with what I have actually mentioned for single container, right? Yeah. So as Rick has mentioned, like the Travis doc, we are finally informing what Docker file should be pushed as a container to Elastic Beanstalk. So those instructions we have clearly mentioned in Travis.yml. So if you go to the Travis.yml, as I already mentioned, it contains instructions of how to deploy the entire application. In our case, it is a very simple application. It is a simple HTML application. These two HTML pages, it will just Dockerize this particular application. It will just Dockerize this particular application and deploy to Elastic Beanstalk. So whether to Dockerize this application or not, we already mentioned it in Travis.xml. So here we say that this service is of type Docker, right? So that means like the entire application will be simply Dockerized by simple command, by this simple instruction. You just say it is of type services, is of type Docker. Travis already knows what it has to do. It has to just Dockerize the entire application into a Docker container and then deploy to a provider. The provider that we have mentioned is Elastic Beanstalk, right? That's what we done in the last session. Okay, got it. Now we learned about the Travis.yml. So these all instructions, actually simple instructions, will actually help us in deploying to our environment. So last week I have given a runtime demo of how this application is deployed, right? But we need to understand the flow basically. So how the flow is happening. So in these instructions, we already see the bucket name and bucket path also, right? So let's understand what does that actually mean. So what actually happens is like this our application is there, right? Our application, my first app application, is actually bundled into a simple zip file. And that zip file is actually first pushed into S3. S3 is nothing but a simple storage, right? It's simple storage. So our entire deploy bundle is created by Travis, and using that bundle is actually pushed to S3 first. And from that S3, it is actually pushed to Elastic Beanstalk environment. So it is two-step things. So you can actually verify that by going into AWS S3 account. Like if you see, you already give the bucket name here, my first app bucket, right? So you can just go to our S3 services. In this particular S3 services, you should be already be having a particular bucket of name my first app bucket. So it should actually match, right? My first app bucket. If you see in our Travis YML, you have already mentioned the bucket name. So, and the bucket path, the folder path, Docker. So if you go my first bucket, and from there you go to Docker, you can see that the bundles are there here. So you can see these zip files, right? These are all application Docker bundles. So our application bundles are first pushed into this particular S3 bucket, and from this S3 bucket, it goes to Elastic Beanstalk application environment. So from here, it actually goes to Elastic Beanstalk environment.
A question. I'm sorry. What is in that zip file? I think that's my question. What's inside that zip file?
Okay, let's see that. Actually, it contains the bundle. I never see that actually.
I'm sorry. It's just I'm trying to kind of.
Okay, let me see. Okay, so this is the zip file we have. So it is exact copy of our repo. So it contains the Docker Compose YML, using which it is actually creating the Docker Docker application. So it contains Docker Compose YAML, Docker file, and our HTML files, which is index.html and this.html.
So it does. Okay. So it has the code. Okay. All right.
Okay.
Right. It's referencing to the HTML. And okay. So all right. All right.
Yeah.
So
So
those are run times on that. Every time you run it, is it a recreation of a zip file on the S3 bucket?
Yeah. So every time you do a push, right? Every time you
Right.
do a push to your Git repo, it actually pushes a copy of bundle into S3, and then it actually deploys to the Beanstalk application, because we have
But that push is only in a YAML file, right? That's the only
no,
push you're doing.
the push in our repo, for every push in our repo. So here in the last section, if you see in the line number 19 and 20, you mentioned that for every push that you do in branch main, if you do any push in branch main, you deploy it into Elastic Beanstalk. So this is the instruction. So it is under deploy section. So that means,
but the only push that you're doing in your main branch in GitHub is any changes you do into the YAML file, right? Is it?
No, entire code, any of the code.
Any of the code. So if you're modifying any of the underlining HTML or Java, whatever it's you're running behind it that you want to render, the question is, you're making the changes in the Docker image, right? Is that correct? That's where you're making the changes, right? Where are you making the changes to deploy? Are you making the changes so the Docker build, or are you making the changes in your GitHub and you're pushing it? That's the question I have.
You're making changes in the GitHub repo. Yeah. So any changes in the repo, whether in the HTML or something like that, Travis doesn't know that. So it is blindly instructed that any push that goes to the branch main, where any of the Git push that you do in the code, right? It will actually deploy to Elastic Beanstalk. We can put more rules on it by changing the rules. Generally, it is not a good practice to deploy for every commit, right? For every commit in main, right? So, but for demo purpose, this is what we have given. Like I can actually show you a runtime demo of how it actually does the push.
Please, yes.
Yeah.
I mean, can we do a quick one that you want to change something on the underlying HTML?
Yeah.
Hey, I'm sorry. I mean, that might have been covered last week.
Yeah, let's do that. Yep. So I will actually make sure that all the environments, I hope everything is already set up. I'll just do a push. Okay. So let me open my repo. My first app. Okay. Now this is my first app. Let me just do a cross check. My first app bucket is the Beanstalk application. I think everything is already set up. I just need to push, but I just want to confirm my first app application, right? Application name is my first app. But here, yeah, so it is matching my first app, and the environment name to which I am pushing is my first app env. Environment name my first app env. My first app env. Okay, so I think everything is already set up. I just need to do a push. So let me do a push here. I will make a simple code change here. I will do like active. Okay. This is a change I'm doing. So I can actually directly push using GitHub here. Oh, I did a lot of changes. What is this? Okay.
Those are committed stuff, right?
Okay, I can delete it. Discard. Now I have only one change. I have changed made a simple change in days.html. So make I am making Saturday inactive. Just for namesake, I'm doing a comment. So I'm doing a git commit. Okay. So I did a commit and I will push it. Push. So I did a push right now. I did a git push. So this is the Visual Studio way of doing push. I can actually do, I could have done it using terminal also. I did a git up push here. So I did a push. Now you can see that in travis.yml in my first app, the build has already triggered. It should be triggered. You can see this, right? Make Saturday inactive with commit.
Yes.
So Travis has picked up now. Now you go into the main. Now you can see the logs, how it is behaving now. And parallelly, I will go to Elastic Beanstalk S3 also. S3 should be having, my S3 bucket should be having that particular bundle. So my first app bucket should have the latest bundle also. Is there a date? So August 14th.
There it is. Yeah.
I think this is the latest. I'm not sure. Maybe this is the latest. And okay, so parallelly, I will actually open Elastic Beanstalk also.
You'll see it
So
running. Yeah.
Elastic Beanstalk application. So I was actually playing with it. I hope that it should be working now. Otherwise, I can just recreate the bundle to make sure that everything is working seamlessly. Let's see whether it has happened. Okay, so it says that deployment is done. Deployment of the application is done. So bundle creation is also done. I think this is the latest bundle. Yeah, so this is the latest bundle, 2919. So bundle came to Elastic Beanstalk. So if things are going good, Elastic Beanstalk should have deployed correctly. But something didn't go well. Yeah, so this is the latest bundle came, make Saturday inactive. This bundle came, but somehow the deployment didn't go well. So it's because of, I think, something else. I was actually playing with some other deployment, maybe because of that.
Is it just deployed to a single node that you have out there
Okay.
in the Elastic Beanstalk that you built, or?
Yeah. Oh, okay. Sorry. So the build went fine. So it was just a wait game. I had to wait for some more time. The deployment went well. So
you're
you can
deploying
see
to your
our
local host? Yeah, you're deploying your local host, or, oh, you're deploying there. I got it. I see it.
So deployment went well. So it deployed successfully.
So that's your endpoint?
Yeah, this is the endpoint. My Beanstalk actually gives it.
Okay, got it. I'm sorry.
So if you go to the
yeah.
Yeah. So yeah, so I had to just refresh my page. So the health is okay, and my Beanstalk has given me a URL. This is the endpoint, right? So I just click on this particular endpoint, and I see my application got deployed. So this is the deployed code, right? So this is the end-to-end scenario. So what would happen is, like, on a single push, Travis.yml triggered the build and successfully ported it to S3, and from S3 it has deployed to Elastic Beanstalk. Cool. So this gives a complete picture of how the continuous deployment has happened, right? So using Travis.yml. So this is not the only way. There are a lot of ways. We have used Travis CI tool to do the end-to-end deployment, continuous deployment. So similar thing we can do using other CA tool also. One of the famous open source tool is Jenkins. So we will also learn about Jenkins, because Jenkins is also very equivalently important, right? So we will also learn about the Jenkins, how to use Jenkins. So first of all, we need to understand the continuous integration, continuous flow, how we need to keep in picture what is the expected thing, right? How it works. And then we can use different kind of tools to achieve the same task, right? Yeah. So Yeah, so this was a simple demo of how to use travis.iml. So here we have learned about uh, many things, right? So just let's keep memorize things so that we are confident enough about what services that we have learned right now. Okay. Where is my presentation? Okay. So we have used Travis CI, and we have used Elastic Beanstalk, and we have also used um, wanted to be okay. Yep. So Elastic Beanstalk, we have also used Amazon S3, AWS S3, AWS S3, and followed by we have also used AWS IAM services. So let's keep these all services in mind, right? So these are the services that we have used to fulfill the complete CD pipeline, continuous deployment pipeline, right? So we learned about the basic thing, how the Travis.yml works, how to create Travis account, and how to use leverage, how to provide different environment variables in Travis, make use, how to map Travis with AWS account, right? Similarly, we can use Travis to integrate with AWS Azure also. We can use same Travis YML to integrate with Google App Engine also, right? So if you want to learn more, if you have requirement for other services, you can just go to the Travis list of all providers, right? So list of all providers, as you have learned for Elastic Beanstalk, for other providers also, you can actually just go and learn the specific syntax. For Azure Web Apps, just click on this particular. Whenever you want to learn about Azure Web Apps Travis integration, just go to Travis supported providers. You will be given, you will come to this particular page, and from this page you can learn that specific service provider specific syntax. So here you can see, to connect to Azure, you have to give the provider name as Azure Web Apps. To connect to Azure Web Apps, and username, password, and other credentials which are specific to Azure only. It is specific to Azure only. And you can just learn more and more about it, like based upon the providers that you have. So today we have learned about like in the last session, and today we have again iterated the same CI/CD pipeline tool, and we have got a complete picture of end-to-end scenario, how the CI/CD pipeline is leveraged. So though the scripts are pretty simple, very simple, but we have learned like how this particular simple 8 lines of code was powerful enough to do the end-to-end deployment on a single push, right? So you can imagine, like you can write test cases also. You can so in Travis, something there is like deploy, there are many other keywords on success, on failure, and other things also. You can do a lot of things, right? If your build fails, what are the actions that you need to do? If you're on success, if you want to, you also seen that on success, we want to push your Docker file into Docker Hub. So some things, so we can do a lot of things. So we can go on learning a lot of things, but the basic thing, we got an idea of how Travis is helping us in CI/CD pipeline, right? All right, so this is what we wanted to do. So I would highly encourage you all guys to actually use, practically implement it, so that you get confidence on the real core of CI/CD pipeline using the existing services. Whether it is AWS, it's pretty good. We have already live demo, and we have already recorded sessions here. If it is AWS, if it is Azure also, you have a way. Now you have a way how to use Azure or any other services. You just need to go to the documentation of Travis and make use of it. Okay. All right. Now what next? Yeah. So this is all about demo of single container application. You can actually go through our session of having multi-container application. So topic 12 is about multi-container application, and topic 11 is about a single container application with integrated with other AWS services. Typical application development, what would happen is like everything might not be a Docker application, right? So some things maybe is some other external application, right? So this particular session, topic 11, gives you a single container deployment, Flask app deployment with Docker, with integrated with other services. Other services you are using other services which are not related to, which are not Dockerized at all, like AWS RDS, AWS Elastic Cache. So these two things, RDS is a relational database, and Elastic Cache is something RDA, Redis version of AWS, right? So you how to actually work with such kind of applications. This is a simple demo of it. So we can go through this, but I would actually recommend you to practically implement by yourself. It will be helpful. Um, so so these two things we can actually learn more. So let's now so we if time permits, we'll come back to these applications, because anyway this 12 topic 12 is outdated. Probably if I get time, maybe like next session, I will update this particular topic with a working model, so that we can actually just go to this particular GitHub lab and see how this goes. By doing a single push, you can see a multi-container deployment also. I'll make it working and demo it to you by next session. But it will give it, but by reading into this session, it will give you an idea of how multi-container deployment can happen. Okay. Now let's go to Jenkins. Now let's have a brief introduction of Jenkins. Okay. So Jenkins, it's we have a lot of theory on how the Jenkins was built. It's basically open source CI/CD pipeline tool, and it's not only CI/CD. It has integrations. It has many other things that we can do with Jenkins. So we will go through it when we actually visit step by step. So we will actually discuss about how the Jenkins architecture, what is the architecture of Jenkins, how we can actually install a Jenkins. So probably Jenkins can be installed in many ways, right? So here we can show how we can install Jenkins on EC2, but we can also actually have a simple Docker version of Jenkins also. We can just deploy in your local machine. We can actually have a just simple deploy of Jenkins in local machine. I will show you a simple Dockerized Jenkins application, and how you can just run it in your local host. I can show you that also. And also I can show you an installation of Jenkins in EC2 instances. People who are interested in Azure can actually deploy in the virtual machines also in Azure. So we have to just follow the instruction steps for Jenkins, and those instruction steps for Jenkins are already clearly mentioned in this particular repo. We'll go through this. We'll go through this repo. We'll read the README of Jenkins and follow step by step. Okay. So Jenkins can be installed in many ways. You can use yum tool. You can, if you are in Mac machine, you can do in one way. If you are in Ubuntu, you can do it one way. And if you are in other operating systems, they are operating system specific. So installation, there are different ways of doing installation. In Mac, you can use brew tool. In if you are in CentOS, you can use yum. If you are in Ubuntu, you can use apt install. And Windows has a different way, right? So we'll go through one installation of how to do a Jenkins installation in EC2. We will go through one way, and how the Jenkins UI looks, how to configure Jenkins at the beginning, user, how to log in as an administrator user, and then how to add more users, how to divide projects, how to create it, how to actually create different pipeline projects, like whether you want to create a single GitHub repo pipeline or a multi-pipeline project. So we'll go through each and everything of Jenkins, and how can you actually make role-based assignments for your projects. So how you can divide testers from developers. For testers, only testers should be able to access their test projects, and developers should be able to access their developer projects, and so on, right? So we will go through that, and we'll also go through the master slave configuration, master slave architecture of Jenkins, and we will also go through like how to write a Jenkins tool. We will actually see that you can, as you have for Travis, you have travis.yml, right? Similarly, Jenkins also has its own Jenkins file, which can be just committed in GitHub, right? So Jenkins file is one of the file that you actually commit in your GitHub, and it has set of instructions to run a specific pipeline whenever a GitHub commit happens, right? So how to, we'll see into how to hook your GitHub repository with Jenkins and perform the CI/CD pipeline. So we will go through that also. So these are the topics we actually will actually go through when you actually visit the entire Jenkins step by step. Okay, so Jenkins is an open source tool. You already know that. So it is not. It is completely free. You can feel free to actually download it and use it as you go. It is a very good learning for us, because you need not be afraid of deleting or afraid of getting charged for using any kind of Jenkins services. So uh, so uh, so Travis is commercial, so you may be little bit, you should be very little bit careful of using it after it comes out of trial period. But Jenkins is a open source tool. Okay, so you can just feel free to download in any of your environment, whether it is Windows environment, Linux environment, Mac environment. You can learn how to download, install. Once you learn download, install, you can just learn more about how to use Jenkins plugins, how what are Jenkins plugins, and how can you use Jenkins plugins for different powerful functionalities in your CI/CD pipeline, right? Yeah. So we will go through all these things practically one by one. Okay. So so why was so again we will come to the basic theory of why continuous integration is actually required, how it is actually improving the overall software development process. So this is a particular example of how it is actually improving, right? So without integration tool, continuous integration tool, what would happen? You can imagine like the delay in projects, right? And every we there is no appropriate proper way of identifying it at real time. A particular, if any bug is introduced, if any deployment problem happened, if any build problem happened, so without the help of continuous integration tool, we cannot actually make it a well framed process, right? So this actually delays the project, the shipping of the project, delays the testing, pointing out to the correct point of contact, how to identify that which commit has actually created the problem, escalating, alerting that particular developer. All those things are a huge hurdle for in process of software development without a proper continuous integration tool, right? So Jenkins actually helps us in that particular thing, right? So issues before Jenkins, these are the issues that we had. So you might be knowing what are the issues that we have without CI/CD tool, right? So developer has to wait for the entire software build to happen. So if there is no appropriate software build process, you have to manually build the software. Manually, you have to rely on a separate build team who actually performs the build for you, and developer has to find out so there is human intervention here, and when there is a human intervention, there is always delay. There it may be error prone, right? So that is a main problem when before Jenkins, when there is no CI/CD tool, then that is a problem that you would be actually facing. So developer has to wait until the software actually built and tested, and then later, after everything is done, you don't know the exact timeline when the report will come, then the developer will come into picture and try to fix the problem, right? So it actually delays the entire software cycle. Okay, so there is no proper iterative cycle happens. There is no fixed time to identifying the bugs in the code, and fixing it and reporting back. There is no proper automated cycle without a proper CI/CD tool, right? So Jenkins actually solves that problem. And because of lack of a proper tool, the software delivery is also delayed. Software delivery process is delayed, and there is sometimes like the appropriate person may not be identified at the right time, and everybody will be pointing fingers on each other, saying that it is because of your build, because of your commit, it has caused a problem, and so on, right? So these are the problems uh, that came into picture um, before the Jenkins, right? So that made there came the requirement of a proper CI/CD tool. So Jenkins is an open source tool. It is a free and open source automation tool, right? So Jenkins is a continuous integration tool that allows continuous deployment, building, testing, and deploying newly created code and releases, right? So um, so it is basically a server-based system that runs in a servlet container such as Apache Tomcat. So it is so we can imagine that Jenkins runs on a centralized server. So it is having a master slave configuration also. So centralized server, there is a single point of contact uh, where actually the real Jenkins build gets triggered up, and from there it has master slave configuration. It has option to actually bypass that particular build, that particular task to multiple slaves.
Anil,
Yep.
yeah, I have one query here.
Mhm.
So Jenkins is a platform where we can, as you said, deploying, testing, those things we can do in that platform, correct?
Yep.
So, and also you said that is the that is running behind the Apache Tomcat server. So,
No,
is that that?
it is not
Uh,
Apache. It is like servlet containers, like such as Apache Tomcat. Internally, I'm not
I
sure whether.
mean, internally that is running under Apache Tomcat server, correct?
Okay. Hmm.
That also we need to install it, correct?
No, 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 no. Actually, it
Not
is not
required.
running. So when it comes it has nothing to do with Apache Tomcat. We need not install Apache Tomcat. All you need to do is install Jenkins. Internally, what server it is actually running, it is pretty much matured, and we did not go deep inside, or we did not explicitly install Apache Tomcat at all. So it is a single bundle. All you need to do is like download that particular installer. In case of Windows, maybe like it is a simple MSI. You just install that particular tool. Install. It is a simple software. You just
Okay,
need
so
to
when we
install it.
after installing that, so we can see including Apache Tomcat server, which is running in the service. Am I right? Or
Yeah, so basically Jenkins runs as a service nowadays. Whether it is Linux-based service, you can see that it runs as a systemctl server service.
Mhm.
So you can enable it to run as a systemctl command. So systemctl command can be, you can write your own service also. So similarly, Jenkins runs as a simple service, normal Linux-based service. It runs as a normal Linux service, which is basically a web app, and pretty much it is running under behind a particular behind a servlet, behind it runs it as a servlet container. Behind that is a web server running inside, but we need not worry about it. It will provide you as a simple web page. It will provide you a simple web-based dashboard where
Mhm.
you can actually configure all your requirements. So it is a powerful web page where you can actually add all the functionalities which are required for a typical CI/CD pipeline. You can customize as per your requirement. So it is a separate ecosystem. So it has provided you a simple dashboard. When you actually install, it is simple dashboard. You can imagine it as like a simple web page. You can just go to local host, or it is deployed. If it is deployed in whether it is deployed in external environment, you can just go to that particular domain
Mhm.
colon. By default, it runs on a port 8080. Okay,
Okay, so
so
can we say it as a business intelligence tool like that?
um,
BA?
So like it's typically web application only, but a business intelligence tool is purpose is different, right? It
Yeah,
is
it's I mean, business intelligence is like a development platform where we can drag and drop to develop the dashboards, front ends, everything.
okay, okay,
So
okay,
without that much source code behind that,
okay, okay, okay. Okay,
everything
so
will be like a drag and drop environment.
okay, so here we don't have a drag and drop environment like that, but uh, it is a web
We
application.
can configure, right? In the
You can
Jenkins
configure
tools,
it.
we can
Yes.
configure the things.
Yes, so you have a lot of checkboxes. You can add user, like you have seen now in IAM. You can just create a user, right? You can
Yes, sir.
create a user like demo user, something like that. Similarly, in
Yes.
Jenkins also, you can create multiple users. You can assign roles to that particular user, and you can assign a specific project. Like Jenkins is basically CI/CD tool, right? So developer wants Jenkins might want Jenkins to perform his own related unit test tasks. He want to use Jenkins for building unit tests for every commit. So he looks Jenkins as a developer project. Testers may want to do the integration testing, other pipeline requirement. Testers might want to deploy in a test environment. Test environment in the sense you can say that imagine that it's a separate machine where he wants to trigger the build, the whether check whether the build is successful or not. After build is running, he wants to test whether the all the integration test, QA test, stress tests all running or not. So all those tests, once the tests are running, he want to check whether deployment is happening successfully or not, right? So he
Okay.
might want to perform all these tasks automatically, right? So to do all these things, he can just do that using help of this web page that Jenkins provides. Jenkins is just like you just log in as a tester to your machine, that Jenkins website /8080, and you will be
Okay.
provided with username and password. The tester can log in as a tester, developer can log in as a developer. And once the developer or tester, whoever wants login, they can actually customize, they can create a separate project of their own. The tester will say that I want to create a test project, which will actually test the entire code, the build of the code, building whether the building the integration test, the deployments, everything I want to test it. So he can create his own project which tests this scenario. So these all scenarios are called as pipeline. So he can actually test, he can configure it accordingly. So answer to your question, we will see how a tester can actually create a pipeline. How we will also see how a developer can create a pipeline. In generally in big companies, right? You are never a you don't have access to the entire thing, right? So it will be role based. So testers cannot see developer specific projects. Developer may not see tester specific projects, and so on.
So
So
user role
all,
management, correct?
yeah, so role based. It is all role based. So we have in CloudX app, we already have a running demo of a small demo of how the roles are divided and how the different projects are completely hidden among each other, so that only testers can see only testers and developers can see only developer specific projects. All those things we'll actually go through it. We will go through it. Yeah.
Okay, Anil. So in that case, the which technology this platform is built actually? Is that a Java or a,
Yeah, Java. It's
okay?
completely built on Java. So, like I mentioned, when it says servlet containers, servlets means they are Java servlets.
Yeah, Java servlet, and also you said Apache Tomcat server. So
Yeah, yeah.
that
Mhm.
also Java. Okay, fine. Thanks.
Yeah. So Java, it was written long back. It is little Jenkins, it is little bit slow when compared to other CI/CD pipeline. Anyway, it is open source, so things are improving, and still Jenkins is leading the market. So many of the companies are actually still really using Jenkins. So it is a very powerful tool to learn actually. Yeah. So how Jenkins actually not only like we can configure as much as possible. It is highly customizable. You can actually build a nightly build, like it works. It will actually, we can actually trigger a job that actually builds the entire source code every night. That's what we can do. That is one of the option. Another method that you can do is like for every commit you can do a build. So it is like continuously build for every source code commit. Like what you have seen in the Travis just a few minutes before, right? You have seen that for every commit, it is getting deployed successfully, right? The same thing you can actually achieve in Jenkins also. So we can actually do nightly build. It's highly customizable. That's what I wanted to just emphasize. So we can just do a nightly build, or we can do a continuous build for every commit. Okay. Yeah, so this diagram actually gives a picture of how a particular commit to source code happens, how the code is built. So it will just give a picture how Jenkins actually can be configured to work on, right? Yeah, so this gives a picture of how the continuous integration happens. Um, so here you can imagine that CA server is nothing but the the Jenkins server. So we have the developer has his access to repositories, and he does a particular commit. So once he does the commit, so as per this step, like continuous build and source code commit, right? So as soon as the commit happens, the CA server, in this case, the Jenkins server will actually trigger the build and try to uh, test it end to end. And if anything problem happens, it will immediately inform the appropriate developer. So we can actually alert the user so that it will help the developer to identify if any problem has occurred because of his recent commit, right? So as soon as his commit, within a fraction, based upon the time it takes to perform the build and which stage of the build the failure happened, immediately the developer will be triggered, alerted about the problem. So it is because of this automated system, what it helps the entire software development process to move steps forward very fast. As soon as the build anything error happens, he will be immediately intimated, and because of immediate because of immediate, the problems may not be escalated, and he can get a immediate solution for it, because the developers knows what the recent commit he has done, right? So it will be very fresh in his mind. So as soon as he is immediately informed, then the he can actually he can actually immediately discover what the problem is and fix it as soon as possible. So that is what Jenkins helps us with. Okay. Okay, so we have this particular slide which actually describes different kind of different tools for doing the CI, continuous integration. So we have already gone through Travis. So this is a wonderful tool that we have already given a demo of, like with simple instructions. We have seen the complete CI/CD pipeline working, right? So similarly, so there are other tools are also in the market. Jenkins is one of them. So similarly, TeamCity, BuildBot, Bamboo, these are all the different CI/CD tools which are in the market. Okay, I haven't used Bamboo. But I have worked on BuildBot a bit. Like Google Chromium, right? Google Chromium is open source browser software, and BuildBot is a Python based CI/CD pipeline tool. So Google Chromium build happens using BuildBot. So this is also very famous tool, and TeamCity is also similar kind of tool. So we cannot learn all the tools for now, but just remember that there are many CI/CD tools in the market, out of which these are the few, right? Travis, Jenkins, Bamboo, BuildBot, and TeamCity. Okay, so we have definitions of each and every CI/CD tool. Similarly, TeamCity. TeamCity is a build management and continuous integration tools integration server from JetBrains. So it is a proprietary software and widely used in the industry. TeamCity claims that it is also widely used. Travis, we have already gone through Travis CA tool. This particular service is a commercial service, and it is highly integrated with many of the providers, as I already demoed you, right? So, mm, so it can be it is built for projects and teams of all the users supported. So it and actually it supports over 20 languages, right? So we have created a Docker kind of Travis YML. Similarly, we can actually support many other applications also, many kind of applications. Okay, now Jenkins. Now we are actually more into Jenkins. We will look more and more into Jenkins. Okay, Jenkins is an open source automation framework. It is completely written in Java. So that answers your question, right? It is used to automate software delivery process via CI/CD pipeline. So Jenkins is completely written in Java. It is completely open source. Okay. So Jenkins is a it is a very good ecosystem. So it supports installation in almost every OS wherever it is possible. It is configurable, very easily configurable, highly customizable, and so configuration is done. Everything is done via web interface. As I already mentioned, you just log in into a web page to configure Jenkins. You log in into Jenkins web page, and there you can configure end to end. So it provides a web interface. Though the web interface is evolving from time to time, it is open source and it is contributed by many people, right? So it's the user experience might not be so good, but it fulfills the purpose, right? So for the first time, you may face trouble understanding the Jenkins UI because there is no proper UX design happened when building the tool, and people from all over the world have contributed uh, in it. So the user experience is not so much good in when it comes to Jenkins, but you have to get used to it if you want to use Jenkins. Once you know the flow, right? Next time you can actually remember that this is the flow that you need to do when you actually work on Jenkins, right? So so it is easily configurable actually. So Jenkins completely works on plugins. You can see that everything is plugin in Jenkins. First time when you actually even Git integration with GitHub is also a plugin in Jenkins. So first time when you actually install Jenkins, right? As soon as the installation is successful, and as soon as you try to log into Jenkins via the web page, it will first as a first step, it will ask you to install some recommended plugins. So you can say that there are lots of plugins in Jenkins. Many people, you can actually write your own plugin for Jenkins also and contribute. Okay, so there are many famous plugins. Many of the plugins are already recommended plugins are there. Other than that, there are many other plugins which can be installed on demand. For if you want to add more and more features, all you need to do is add more and more plugins to Jenkins. So everything is plugins in Jenkins. So because of this plugin architecture, Jenkins is easily extendable. You can customize your Jenkins app server services very flexibly because of its plugin architecture. You just need to add a plugin if you want to extend the feature, add a feature. You just need to add a particular plugin. So we will go through how to use a plugin. We will run a demo of how to install a specific plugin. For in our case, like role-based application, if you want, it is also a plugin itself, right? So we will see how we install a particular plugin in Jenkins and how do we use that particular plugin, right? Yeah. So distributed. Okay. So distributed in the sense like Jenkins actually works as a master slave architecture. So master slave, you can imagine a slave is a completely different node, right? Jenkins basically works on nodes, right? So the master will be running on one particular node, and you can actually add as many slaves as possible to Jenkins. There can you can you can add slave 1, slave 2, slave 3. Slave 1 can be on Windows operating system, slave 2 can be on Linux operating system, slave 3 can be on any other operating system. So you can go on adding slaves to the master. So it is highly distributable, as far you can say. So the master can actually uh, actually um, pass all its load to one particular slave. It can say that, okay, I got a one particular trigger built. Now I will assign this particular task of testing and building to a completely different slave. It will just assign whether it if you suppose you want to build a particular repo which is a specific to one particular operating system. The build should be happening. Suppose a particular native C++ code, which works only on Windows environment. So that master can actually delegate that particular task to a Windows specific slave. It can say that, okay, this is a Windows build that I need to build. So it will assign that particular task to a Windows slave. So that way the Jenkins process can actually distribute all its tasks to multiple slaves. So it is highly scalable. That's what we can with that's what it is meant and designed for. Okay. Okay. So this is all about introduction about Jenkins. And right, a typical CI/CD pipeline, what are the different steps of a simple Jenkins pipeline, right? You can see that, right? You can see that these are the rounded symbols with different steps as you go, right? So there is a code commit phase, then comes the build phase, then comes the test phase, then comes the release phase, then comes the deploy phase, right? So this entire steps can be looked as a Jenkins pipeline, right? So this diagram gives you a picture of what exactly a typical Jenkins pipeline looks like. People can customize it in a different way, but 99% of the time, when you say about Jenkins pipeline, you can imagine this is a picture uh, of a Jenkins pipeline, right? All right. Yep. So this is about a brief introduction about Jenkins. Um, Let me take a 10 minutes break, and I'll get back. So prior to that, in 10 minutes, maybe like we can um, you can do some research on Jenkins and probably learn more about it. I'll get back to you in 10 minutes. Probably in 10:10 I'll get back and we'll continue from there. Okay.
Okay.
Okay, welcome back. Okay, so we had discussed the brief about Jenkins, right? So we have discussed how Jenkins actually was introduced. Jenkins is an open source project, and how Jenkins actually solves the real-time problems of during the software development, and how does a Jenkins pipeline actually look. So that is what we actually briefly discussed about. And also we have briefly discussed that, which is very much required for everyone to actually remember that Jenkins, these are slides which actually helps us what exactly Jenkins is built upon, right? So we have to always remember that Jenkins is built upon plugins. So everything is plugins in Jenkins. We can just add more and more features. You can extend features of Jenkins by using plugins. So we need to remember that when it comes to Jenkins, you also always have to remember that plugins plays a key role in any kind of Jenkins environment. Okay, so how Jenkins is extensible, how is it distributed? So remember, always remember that Jenkins actually has a master slave architecture. You can add as many slaves as possible, right? So this is the main core concepts that we always have to remember. The plugin architecture of Jenkins, and uh, master slave model of Jenkins. So these things, this should be good enough for visualizing how actually a Jenkins actually works, right? So this is an example of typical Jenkins play pipeline. So we will actually visit these slides again and again, so that we can practically we will implement few things, and then we'll come back to the slides and match with what the theory says and what we are seeing practically. So I think that would be a very good approach. So 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 let's just jump into how a Jenkins dashboard looks like. Okay, I think I have a Docker of Jenkins already running. We can actually run a Docker container, Jenkins Docker container. It's very simple. Uh, now we all are good at Docker, right? We can just play with Docker and see if already a Jenkins is running in there or not, right? So let me see in my Docker if I am already running Jenkins. I will say Docker PS to list all the containers, not non whether it's running or running. Let me grep the name Jenkins. Okay, here I go. I have a Jenkins container running. Whether it is running or not, let me check. So I will remove -a will list all the containers, whether it is running or not. I will remove -a and I will just run Docker PS. So, okay, so it is a running container for me. So I can see that there is a Docker container running with Jenkins image. Okay, now it is, you can see here that it is running in port number 8080. So I have already configured it to map with my host machine 8080. So I think it should be just good enough for me to run localhost 8080. Yep. So I'm good to go. So this is what a typical Jenkins looks like when you log in, when you try to log in. Not for the first time. I am doing it many times. So I just logged in. So I logged in as an admin. So when you actually first time configure Jenkins, right, it will ask for admin credentials, admin username and password. So this is typically how a Jenkins dashboard looks like. You can always configure the dashboard look and feel. So people can actually install a separate UI plugin to change the look and feel of Jenkins, right? So this is the default look and feel of Jenkins that comes up when you first time install in Jenkins and log into the Jenkins, right? So here you can see that there are this is what a typical dashboard of Jenkins looks like. So you can go to different pages. You can come back to the home page by clicking on the dashboard. So once you click on this particular dashboard, you are back to this, right? So your typical Jenkins default Jenkins dashboard will contain a list of projects. It's like whether it is a freestyle project, whether it is a pipeline project. So this all are the projects that you are running in your Jenkins environment. So this is a typical Jenkins list of all projects that you are actually looking into. So this is what the Jenkins looks like. It has imagine that you already are running some builds the Jenkins, then you can look into the Jenkins build history by clicking on build history. Here you can see a typical build history of a particular project, particular pipeline, right? So it should be easy for all of you. If you are running a Docker installed in your machine, you can just install a Jenkins Docker container in your machine, local machine itself. So it's a simple one-line command, I suppose. Just type out Docker Jenkins Docker run. Okay. So go to the official website of Jenkins.io. Here you will be given an instruction of how to run a Jenkins in Docker environment, right? Okay, so these are all optional. So all you need to do is simple Jenkins run, right? So maybe I have better. So in Docker Hub, we have an official website. You can just go to our Docker Hub. And go for Jenkins. Type Jenkins. Right? Now you have Jenkins already here. So this is what you need to just run. Okay. Now Docker pull Jenkins. It's a Docker official image. So all you need to do is run this particular. So they mentioned that this image has been deprecated. So probably you have to go to Jenkins website. Okay. Okay, so this is the latest supported Jenkins Docker version. All you need to do is run this particular command with the port number of port number 8080. Okay, so generally by default Jenkins actually runs in port number 8080. Always remember that you need to map that port number 8080 with your host machine 8080. So in order to map that, you need to run this command -p with command -p. So let me show it to you. So here, here I already mentioned this, right? So this is what I have run. So all you need to do is Docker. So you can just, instead of pull, you can just run Jenkins. So Docker run. Mine may not work now because I already run the same command. So Docker run -p 8080 to 8080. So this will simply download the Docker container, Jenkins Docker container, Docker image from Docker Hub, and it will run the Docker container for you in port number 8080. After you run this particular command, right? After you run this command, your Jenkins application is ready to start. Okay. So once you are ready to start, you will be provided with the file UI of what is the first user you need to add. It will ask for you. I'll go through step by step from scratch. Okay. So how to show you? Basically, I already started it, right? So probably the best way to do it. Okay, let me delete this for you. I will delete this. Mm. So here the instructions are very clear. To simply run Jenkins like this, you can just run Jenkins like this. Or if you want to have a specific customization, then this is the way you actually run. So for now, this should actually work. Simply running this command should actually work for you. So let me delete my Docker container for you first. So all you need to do is stop. I will stop this container. So remove the container. I remove the command container. So there is no Jenkins running. Let me check in images. So I deleted the container, but the image will be there, right? So I already have this image. Jenkins Blue Ocean is there, but image is there, but I am referring to different another image, right? So this is what I am referring to. So just run this particular command, Docker run Jenkins. So it will pull Jenkins from Docker Hub. Okay. So now what you are saying is like it is trying to search for Docker image, and I think we need sudo. We need to run in evaluate permissions. Okay. Is my Docker desktop running? It should actually work. I don't know why. Let me go for a specific tag that they are mentioning. So Jenkins with tag 2.6.0. Will it work? Okay, so it is not compatible with Linux ARM v64. Okay. Okay, I have to find the proper image which actually works with my Mac machine. It's with Alpine, it's a Docker file latest. Yeah, it should work, right?
Use sudo again.
Okay.
Just sudo again. Go
Yeah.
back to your terminal. Yeah, try sudoing now.
Okay. Okay. This image doesn't work. So I think last time I faced the same problem. For that, I actually downloaded DigitalOcean. So maybe I have to reuse that. So if I say images, I have digital Blue Ocean version of Jenkins Blue Ocean. So let me
It's
see.
use the same tag, 232. Go back. That image, you have a tag.
Yeah. So this image is completely different from what is there in Docker Hub. So let me search for that particular.
That tag, yeah. Search for that tag.
Okay. So Blue Ocean is provided from some other user, which is working fine. Okay. So probably I can actually just run this now. So I will say Docker because I already pulled the image already. So I'll just run this particular image. This Blue Ocean with tag 2.3.1. Okay, so it started running. Oh, I should have run in detached mode. Anyway, so now I have made a container version of Jenkins running. So here you see that there is specific key, right? A special key that is coming here, right? Just to make a note of this particular key. You might be interested in you might have to enter this particular one-time administrative password when you actually go to the local host. So go to localhost 8080. Oh, did I map 8080? Let me check whether it works or not. No, I didn't map. So that's the problem. So I have to cancel it anyway. So let me see if I have any traces pending there. So I have to delete them. So where is Jenkins? Can you see that? So let me delete it. It is, I have to stop it. Okay, now I stopped it. I removed it. Now Docker run with port information -p 8080 mapped with Docker containers port 8080. Oh, again I forgot. Shit. Under detached mode, I should have run in detached mode. But anyway, it will work in foreground as a foreground process. Now let's see if it works. Okay. So the Jenkins is running now. It is running as a foreground process. I should have typed -d option. It will run as background process. But anything is fine. For now, let's make it running in foreground process only. Now, just make a note of it. This copy this particular administrative password, which is given to you in this terminal. Otherwise, you can just go into your Docker container in this particular folder /var/Jenkins home /secrets/admin password. So this particular file will contain this administrative password, which is one-time administrative password. So just copy this particular admin password, copy it, and enter here. So this is only for the first time. For the first time, Jenkins will ask for this administrative password and click on continue. So after this, as I mentioned that Jenkins is all about plugins. Jenkins will ask you to install suggested plugins. Now these suggested plugins are very much required. This is almost 100% required. So you just need to install these all plugins. So it will try to download from all these plugins and install it in your Jenkins service. So here you can see that there is a Git pub plugin, right? Git plugin, this pipeline plugin. These are the core. These are the core components. SSH build agent. These all are core components which are pretty much required for any Jenkins service to run. So just install the recommended plugins, and it will download and install all these basic plugins, right? So previously, all Java projects we used to run on Ant projects and Gradle.
So
Um,
here we have email extension as well.
yeah. So email extension, yeah, it's there in email extension also. Yeah.
In
So
that case,
maybe
SMS also will be there.
SMS, it looks like it's not there, right?
Okay,
Um,
like Twilio we will use, right?
yeah, Twilio is a external service. So probably there may be plugin for Twilio, but it is not in the recommended plugins of when we first time install them.
Because I am seeing that email extension, right? So my
Uh-huh.
mind got to know about SMS also.
Oh, yeah, yeah. Yeah, so email extension, okay, it was not successful. Email extension and plugin pipelines are not successful. So probably we might want to retry it and see if it works fine. Okay, yeah. So these are the basic plugins which actually Jenkins core team actually recommends to install. Okay, so SMS may not be the recommended, but once you actually after successful installation, once you get into the dashboard, you are always provided an option to add as many plugins as you want. So it is asking for a new username and password. I will just enter a username and a password of my choice. Just enter my name and email ID. Maybe.
When we are saying that email extension, Anil, so I have one question here.
Okay.
In our scenario, we have the web jobs. Okay,
Web jobs. Okay.
web jobs. So at present, in our projects, we have deployed in the Azure.
Okay.
Okay, and we are scheduling that web jobs. So from that Azure, the report is every day. Report is going to the mail IDs. We are scheduling and we are sending the mail to the customers and all. Okay,
Okay.
reports.
Okay.
So in that case, when we are, can we able to schedule and provide the email from this Jenkins tools? Is that possible? Web jobs
Yeah.
and all.
Yeah. So nowadays, email has become a default for any kind of applications. I am pretty sure that Jenkins will have a very handy way of sending mails. Like when you actually run an
So we
IT.
can deploy the web jobs and also we can schedule it.
Yes, yes, yes. We should be able to schedule. We should definitely email is the maybe like the fundamental thing nowadays, right? So definitely we should be able to configure any kind of sending build reports and sending email to
Correct,
different kind
correct,
of
correct.
users and developers. Definitely it should be there, right? Yep. So probably it should be as simple as just send email option. If the email SMTP everything is configured correct in Jenkins, I think it should be as simple as a checkbox for every project build. Just send email also. It should be as simple as that. You need not actually go write any code for actually deploy sending
Yeah,
emails.
it's a kind of just a configuration, correct?
Yes, yes, yes.
So for that, we need to install that email extension as well, or
I think so configuration of email might be mandatory for the first initial setup. I right now exactly don't remember the steps where exactly we configure the email, but
okay,
that is a very simple steps that we need to follow to configure email. I will show you.
okay,
I will show you if I come across here somewhere. I will just show you.
okay, yeah.
Okay, now we have Jenkins configured. It asked me saying that give me at least one user where you using which you want to log in every time. I entered the username as admin and I entered the config password of my own. Now we are good to go. So it says that your instance is ready and your instance URL is localhost, port number default is 8080. Okay, now you just save and finish. So Jenkins is ready. It is asking to restart the Jenkins and click on Jenkins and you are good to go. Now, what are the steps that you follow to start a Jenkins? It's very simple. You just run a simple command in the Docker. In the Docker, you just run a simple command, right? So basically, what is like the entire Jenkins installation, everything is already happened inside the Docker instance, right? And you just need to run that particular Docker instance. I'm not sure why Docker Hub official website was not working fine. Ideally, this Jenkins should work. So people will generally go to Docker Hub and just type Docker. And when they see Docker Hub Jenkins, this particular image should defaultly work. I'm not sure why it gave an error to me. I tried with the tag also, but it gave me error. Maybe like in my Mac machine, it is not compatible. I'm not sure. I think I remember I did the same thing a few days back and it didn't work. So I opted to go for okay, it's fine. It's about installation of pipeline failed, right? We look into it that later. So basically this official website should work, right? So I would encourage all of you, please try out in your machines. You just need to type the same command that I have typed, right? I'll just post it. I'll just post it in our this one chat. So I would actually say that you just try to run in your machine. If your Docker is already installed, you just type Docker run that Jenkins image, Jenkins image with the tag. Where is it? Chat. Okay. So just type this particular command, Docker run Jenkins. Jenkins, generally it will take the latest tag. You need not mention. If you don't mention anything, it will take the latest. Ideally, it should work. Ideally, the Docker run Jenkins with the port number -P, and defaultly Jenkins always runs with port 8080. You map your machine IP address with 8080. So this command should ideally work. This should work for machines. I don't know why today it was not working. I will try
Excuse me.
offline and see.
Did you use the Jenkins /Jenkins.lts?
Okay.
This one up here.
Yeah, I think that is what I should do. But he should have said that also. Okay, let me try that actually. Yeah, that's a good thing. Let's try that. Okay. Where is my? How do I stop this? Where is my window? I actually started the Jenkins. Okay, the Jenkins is already stopped anyway. Okay, so let me try that. Jenkins PS is the Jenkins running. Docker PS -a grep Jenkins. Okay, it exited. My Jenkins containers just exited. You can see that it is in exited state. I will just stop it now. It is exited, right? I will remove it. Command not found. Docker remove, sorry. Okay, I removed it. Let me just verify it. There is no Jenkins. Now I will actually run it again. Docker run -P 8080 and what he recommends is Jenkins/Jenkins, right? And that should be enough, I think.
No,
so.
LTS.LTS.
Okay, by default it should take LTS.
No, LTS, yeah.
Okay, LTS. Okay, let me try this. So shall I type sudo?
Oh.
Let's see. Oh, it's working. Cool. Yeah.
Okay.
So we should go to that account. So Jenkins slash means like it is like Jenkins repository. Jenkins repository slash Jenkins LTS. Okay, cool. It worked. So Docker Hub.
Anil, I have one query.
Mhm.
So here, if we are using 8080 in some other application or some other software, can we use any other port?
Yeah, yeah. So here you see two parts, right? 8080 dot slash 8080. These are two parts, right? So
Okay.
this right side is Docker specific, which you can't change. So Jenkins internally within inside the Docker runs in port 8080. And this left side part 8080 is our choice. So if our application is already, if our machine is already using the port 8080, we can run our in any other port also. So like I can show you right now itself.
Yeah, I got it. Actually, for example, in .NET, we will host it in IAS. So in IAS, we will give the unique port number.
Yeah.
When we are creating the website web apps, it should be unique for
Yeah.
every websites. Yeah.
Yeah, if the port is already occupied by other application, then we have already have a choice to change the port number. So here
Okay.
you can just choose 8081 in this case, 8081 colon 8080 again. So this right side you can't change. Right side is already decided and it is already configured within the image of the Docker. When the Docker image was created and uploaded into the Docker Hub, right? At the time
Mhm.
on, it is already decided that the Jenkins will always be running on a port number 8080. That's what this right side 8080 says. But you have option to map that internal port of Docker 8080 to your local machine port, whatever of your own choice. Where you can just change it to any other number. Okay, so
Okay.
look
So
at.
in that case, can we able to give the as you are aware of DNS, right?
Mm, mm.
DNS name, alias name. So can we give that local host 8080 colon 8080 like that? Can we give, or how can we give for the DNS?
Oh, actually, here basically Docker run one works on always on local host only.
Mm-hmm, mm-hmm,
Uh, so in the machine where you are actually running, right? So it will
mm-hmm.
take the machine as its default platform that you can say. So in this case, so when you run in this particular terminal, right? You are inside. I am inside Mac machine. So it will take the Mac machine has the input. Whether your Mac machine is internally exposed to is mapped to a different DNS address, that's a different scenario, which typically happens in any production machine, right? So whenever you actually deploy in a machine, whenever you deploy a Docker container in a production machine, you go inside the production machine and you actually run the same thing, like Docker run this command, you run it. The production machine internally will be mapped via any complex tool, whether it is Apache, or whether it is nginx, how it is mapped is a completely different topic. But
No, no. Actually, when we are saying that DNS mapping, right? So we will have it IP address, that particular system IP address, correct?
yes, yes,
So that IP address should map with the DNS.
yes, yes,
Then we can launch the application by using the DNS itself, correct? That is the
yes,
actual procedure and actual steps.
yes, yes.
So here, what I am my query is here 8080 colon 8080. So when we are giving for the mapping to the DNS, so we need to give with IP address colon 8080 itself, or again colon 8080. That 8080 also we need to give.
No need of giving IP address. We default to generally we just give the port number itself, and IP address will by default will be mapped via the DNS, right? So this
Mhm.
IP. So here, what you are saying is like you are mapping your machine port number 8080 to Docker port number 8080.
Correct, correct, correct. That also do we need to share for the DNS
Yes,
creation,
yes.
or
So, no,
it's
no.
not?
You no need of sharing to your DNS. Basically, your machine etcd host configuration or any other configuration, uh, the local host can be mapped to any other IP address or domain name. It is next level that once the domain name is mapped, I'm telling one particular scenario. There may be many scenarios. One typical scenario is the machine where you are actually running the Docker. That machine itself will be having some static IP. Imagine it will be mapped with a static IP address, and that static IP address will be mapped with a domain naming service, DNS service. So finally, at the end of the day, your machine can be accessed via a DNS, okay, via some
Correct.
DNS, something like
Correct.
mydomain.com. But
Correct.
if you want to use your Jenkins application, then you say that mydomain.com colon 8080. So
Okay.
within
So
the
it will get append when we are using this Jenkins, correct?
yeah, it will automatically get upon. So it is
Okay.
it is to the local machine level. In the local machine level, for the entire local machine, 8080 port is already occupied for Jenkins. You cannot use this port for anyone else. Whether you need to expose this port to the external world or not is a separate firewall configuration. Like if you are in Ubuntu, you have to open this port for the external world. All you need to do is like now internally you can access it via localhost by this particular simple command. By this simple command, this port is open. So this port is open, 8080 port is open. But this port should be exposed to the external world or not is decided by other factors via firewall or something else, right? So once the port is open for the external world, whatever IP address is assigned to your machine combined with the port number 8080 will always go to Jenkins application.
Right. So my question, I think I know where he's going with this. In a multi-development environment, you would have this under a VPN, a private virtual cloud, where everybody is developing and is pointing. And if you want to deploy, you deploy through the mapping of the router through a exposure to a DNS, a public DNS. You would kind of work in that type of environment. You're inside a VPN. All the developers are inside a virtual cloud. Would that be correct? And then we'll be working in our build inside that private cloud. Is that right? If we were working in an IP, like a, everybody's working in the cloud base. Is that, I think that's what I think. So we're all interacting through a local host or to the port opening of 8080 and in itself, but we're deploying, when we deploy, we're deploying outside the VPN in a DNS public exposure to anything that it's built. Is that right?
Yeah. So when you say virtual cloud, right? So imagine that you are in a AWS cloud, AWS machine, easy to machine, right? So AWS is already has done the homework of mapping your EC2 machine to the external world already, right? So let me quickly show you one particular example with some example. So it's let me go to AWS console here. I will go to, I hope I already have one EC2 instance running inside me. So I just go to instance. So, okay, I have two EC2 instances already running. Okay. So when you create a EC2 instances, right? So there are a lot of homework already Amazon actually does for us. What it does is like, EC2 is just a simple machine, right? Single machine, but you should be able to access that particular machine, which is there in Amazon WS from your local, from your laptop, right? So for that, what it does, like there are some set of inbound rules and all those things, which Amazon does that for us, right? So I'll just show you the security group here. So imagine EC2. This EC2 is nothing but a simple operating system, a Linux machine. You can imagine this particular machine with name I07E something, right? So this is a simple machine. It is a simple machine. It is given the name, this complicated name is given given to it. Okay. And this particular machine should be accessed. It is somewhere else residing in the data center. This particular machine is residing in the data center. But you are sitting from in your home and you should be able to access this particular machine, right? To access this particular machine should be open via some port. Some port should be open, and you can access to that particular machine via the port. If you are using HTTP protocol, the general port number is 80, right? And if you are using SSH protocol, the general port number is 22, I think so, 22 or 20, right? So those all things are defaultly in security tab. In security tab, you go to security groups here. Go to security groups. You can see that there are some inbound rules here. So inbound rules, you can see that inbound rules.
It is same like sure, correct? No.
Yeah, Azure also follows the same.
Yeah, same inbound rules and outbound rules are there.
Yes,
Yeah,
yes.
I mean, that's all. I mean, I
Yeah.
don't mean to interrupt, but I know most of this are
Yes.
words, but what I'm trying to get at is, you know, how am I working in a Jenkins environment, like say with one of my colleagues here, and we're working together on a Jenkins build without having to go through the CI/CD pipelines that we would either generate using Amazon's because they have their own one, or maybe using an outside, let's say Docker environment such as Travis. How is that set up where we're all working together on this build and we're all kind of like pointing to the same Jenkins machine? That's what I'm trying to, because I'm familiar with the security inbound and the outbound, the port 22 and the defaults that go when you build a security group and the ACL also, you know, what you can limit in and out from a public domain perspective. But what I'm trying to say is how I'm trying to have a picture how this will work together for working in an environment like with Sakarama and the other colleagues, you know, how we'll be working on that. I think that's what I'm trying to, and I'm sorry, I'm just trying to visualize that.
Yeah, you have a very good point, right? So it is as simple as we have to deploy our Jenkins in any of the cloud environment to work as a team where all members can actually access the Jenkins build, right? So for that purpose, you just need to create a EC2 instance, whether it is AWS. If it is Azure, you create a virtual machine in Azure.
And I would point to the same edge, right? That same environment that he would go in and point. Exactly. Is that what it is? Yeah, I got it. Okay.
Yep. So just deploy Jenkins in that particular common accessible EC2 endpoint and create an inbound rule 8080. So everybody will be able to access that particular Jenkins dashboard from their to the common EC2 instances. So we will actually do that step by step later.
Okay.
Yeah.
Because we would have to save that image that we're all working on that environment, right?
Right. Correct.
Right. So that image would have to be saved somewhere in the AWS repository, and because we would need to know that we have to point that to that image, right?
Oh yeah. So we need not rely on only image way of deploying Jenkins. We can just install Jenkins directly inside the machine itself.
Okay. Right. But the machine has a particular. We would have to all point to the same machine.
Yep.
Eventually, right?
Right.
So we would when we create our instance, we have to pick that image or pick that virtual machine.
Yes,
correct?
That's true. Yep.
Right. So that machine needs to be registered in the AWS or in the service, so we can pick it up, right?
Yeah. So when you actually create a EC2 instance, it will by default give you a public IP or a public endpoint. You just need to use that particular instance.
Got it. Okay.
So here there is a public IP address, right? So this is my EC2 instance. For example, I already created one EC2 instance, and this is the public IP address. It is already exposing. This is the public IP address. It also has a public exposed URL also. Public endpoint will be also be there. You can actually use it. So it is as simple as going to this particular URL. I think it's already working. It should be working. I'll just show you.
So I hope that the public IP will expose to the
Yeah.
internet application also. Correct. I mean, we can expose that public IP to the outside of the environment
Yeah.
anywhere.
Yes, yes. So the public IP is meant to be should be accessible from outside only. Um, so there for every instances that we create, right, for any virtual machine or EC2 instances, there are two IP address that will be given to us. So one is the private IP address, which is accessible within the network, within the VPC network, which cannot be accessed via browser from outside. Uh, and another thing is a public IP address, which can be accessed from outside. So in this case, this is IP address which AWS has already configured for us and which can be accessed from outside. All we need to do is like use that particular IP address, and already know that Jenkins is running under by default is running under port number 8080. I just need to type 8080 port. So public IP address, comma, 8080 port will actually give me the Jenkins instance. Means like I already installed a Jenkins inside the EC2 instance. Just I'm accessing that like this. So I just need to type
Got it.
the
Got it.
password.
Yeah, I see it now.
So in that
I
case,
mean,
how the security perspective, Anil? How the point of view, security point of view,
Yeah,
how it will
so unless
applicable?
you can access the it is supposed to be if you can actually expose this particular machine to the public IP only if you want to, right? So if you don't want to expose this IP under 800 port, you can always remove this
and in the
uh,
AWS, you can remove it
from
when you
from
create it.
yeah, here 80p2 I exposed it, right? All I need to do is that edit this particular security group, and I have to edit the inbound rules, and I will remove this 80 port entry. I just need to delete it. Only
You
if you
can
want to.
also, right, that's it. You can also delete it or not have, when you're creating the image, I believe you can say, I don't want a public IP. Is that right?
Huh. Yes. And you can actually restrict it to only specific users. Here you have said 0.0.0 so that everyone can access it. But if you want to access only to specific people only, so that is something AWS has made us easy for us. You can just select my IP. So that means like my IP in the sense my IP, the machine where I am actually working on right now. So AWS somehow finds out my IP address. My IP address is 49.20.251. So nobody else, even though it is exposed, 8080 port is exposed, only I can only access it. So it gives a access to only this IP address, and no other one can actually access the Jenkins. But if you want to expose to everyone, I can say provide access to everyone. So that means that is 0.0.0. You can go on adding more and more here. You can actually you can provide your custom, you can create your own kind of list of IP addresses. You can say some 121 dot something, some IP address, comma, /32, comma, some other IDs. You can provide a list of IP addresses only, and your application will be exposed to only those IP addresses. So that's why that way you can actually restrict the access to your application. Got it, right?
So for that Jenkins, the dashboard is just for visibility, just for to see what's running or what needs to be. That's really that's all it does, right? Just gives visibility what jobs are being
So
built
basically,
and logs and
visibility in the sense you will provide the application is accessible to you, and the next step is if you have the username and password, then you are inside the application.
right. But in essence, that in the real world of production, nobody really accesses the Jenkins, only the admin or when there's an issue or for log purposes, right? Is that right? Just to monitor what builds were done and and what was deployed, because at the end, you're just going to go somewhere to see the results, right?
Yes.
You're going to go to an IP address and see what the results of the build is,
Yes.
right?
Yeah.
Okay.
Yeah.
Thank
So
you.
I
Thank you
think I
for this.
remember my password. So you just can log in to the Jenkins like this. Now we are inside the Jenkins, which is deployed in EC2 instance. So we already have step-by-step instructions of how to deploy Jenkins in EC2 instance. It is same to same steps we need to follow for Azure instances also. So there is no difference. Here in AWS, you just create EC2 instance. In Azure, you create a virtual machine. So once you have the virtual machine, you just need to follow the steps. I think we have the steps to actually install. So this GitHub link as provides us the steps to install Jenkins in any of the cloud, particular any machine, which this steps typically works on Yum package manager. So basically, it works fine with CentOS machine. So when you create a virtual machine, uh, just install a CentOS, create a CentOS 8 version based virtual machine in your EC2 instance, and then you just need to follow the steps, and you should be able to install Jenkins. So here you remember this in our machine, we use Docker uh, to start a Jenkins instance, right? So we did it is like we just pulled existing Docker image and we just run that particular image and we are ready. But here we are we are downloading the Jenkins installers, Jenkins software, Jenkins artifacts. So you just need to download the Jenkins artifact using Yum package manager and install. You have to install few prerequisites. One of the prerequisites are Java. You have to install Java and then followed by Java specific configurations. So you have to set the Java home path, set the path, and all those things. And after you have the basic prerequisite of Java installed, all you need to do is like install Jenkins using a SQL command. This is what the Yum way of installing Jenkins is. So these steps will actually install Jenkins for you. So you can see the last step is like yum y -y install. -y means silent install, silently install instead of asking for confirmation and all those things. So you can just install Jenkins. Once you install this Jenkins in your EC2 instance, once you have created the EC2 instance ready with Jenkins installed, all you need to do is, as I already mentioned, there should be a inbound rule, 8080 inbound rule exposed with this port, and you are good to go with your Jenkins dashboard. So this is your Jenkins dashboard already ready. So anyway, so creating a EC2 instance should be pretty straightforward. I will actually go step by step of installing Jenkins in EC2 instance step by step next session, so that we can uh, get a feel of how we can actually access Jenkins uh, in a EC2 instance. Okay. So here this just I am showing you, but we will again iterate through the steps next week. Next week, we'll go through how to install and how to use what are the different features of Jenkins, how to add plugin, how to make a role-based authentication in Jenkins, all those tips. We will go step by step in next session. For now, so we are out of time. So have a good day.
Okay. Just a last one query.
Okay.
Do we have a JVM in this picture? I mean, in this, I mean,
Jenkins is basically a simple Java. It's a Java application, so it definitely requires JVM.
JVM
Uh,
is required. Okay, okay, fine.
Yep. So one of the basic prerequisites of Jenkins is it should have Java installed. The machine should have Java installed. So Java 11 latestly,
So along with the JDK,
yeah,
JDK is
JDK.
required to install.
Oh, you mean JDK and JVM, right? Oh, that I
Both is required or any one is
no.
required or
Only JDK. Yep.
JDK?
Only JDK is sufficient. Yep.
So after
Okay,
you,
fine, Anil. We will discuss in brief in the next session about the
Okay.
installation.
Yeah, Rick, please. You had some
Yeah,
question.
once now you're going backwards because now we're loading up Jenkins on the CentOS machine. And then would you have to load up your Docker in that same machine? And then, because you're pointing to the same ports, the 8080 port, would you say that then that environment is already, Jenkins understands it to be working under a Docker container environment, or
Oh, no.
how?
Once if you follow these steps of installing Jenkins in EC2, then we don't need Docker.
Right. But
Um,
let's say we're running under, we're developing under containers, right? In a container environment, right? Because
Oh, then
we're all
okay. So then we need not
containerizing.
follow these steps actually. Then we don't need to install Jenkins this way. If we install Jenkins in a Docker way, then we might not need to install Jenkins again inside the EC2 instance. We
Correct.
just yeah.
Correct. I
So
got it.
so probably your question is, we can make it working like we can install Docker version the installation in the EC2 instance, and also we can make it running install this way also both. But in Docker instance we have to expose in a different port, probably 8081.
Okay.
So that means like we will be running two Jenkins dashboards in the same machine, one in the Docker, one in the real EC2 instance. One Docker will be exposed in 8081 and the real instance will be exposed in 8080. So which we might not need actually. We want only one Jenkins instance, one Jenkins server to be running. But if you want multiple Jenkins servers to be run, we can do that way also. Yeah.
Okay.
Yeah.
That's all. That's all the questions I have. Thank you very much. Very, very good.
Okay, Rick. Okay, let's have a discussion next week as well. So we will continue from where we have left. We will again try to deploy multi-container deployment of Docker next week. And also we will continue with EC2 Jenkins dashboard creation and how to work with other features of Jenkins. We will look into it next week.
Thank you.
All right then. Okay, thank you. Thank you
very
all.
much. Thank you.
Thanks, sir.